Hello, this short video is a clarification for homework number 4 for the construction of table number 1 on a two-way ANOVA example. Okay, let's go ahead and talk about what I have here. So this concerns the two-way ANOVA writing guide with the example that we talked about. And one thing that's unique about the two-way ANOVA is that the outcomes look a little bit different depending on whether or not I have a significant or non-significant interaction term. In this first example, I have a non-significant interaction term. And I wasn't clear exactly how table number 1 was constructed when I talked about this in class. When I have a non-significant interaction, I can consider the two factors independent of one another. So I can look at shelf height, top, middle, and bottom, and I don't have to worry about what shelf width it is. Now, when I do have a significant interaction, then I need to worry about the combination of those two factors. So let's put this in context of our bakery example here. In our bakery example, okay, the interaction term was not significant. So what that means is I can consider the effective shelf height and not worry about the shelf width. So for example, if I want to compute the row for shelf height bottom, I would consider these observations right here. And I would simply compute the average of these four because that's for the bottom shelf. The average for these four, you can get here in a spreadsheet down here in the status, is 44. So that should be the value reported there with the bakery example. Bottom 44. There were 4 observations used in that computation. It'd be these 4 right here. If I'm getting the average for the middle, then I would just use these 4 here. Likewise, when I'm doing the shelf width, I would consider the regular shelf widths. And again, I don't have to worry about if they're in the bottom, middle, or top because the interaction term is not significant. So compute the average of these two, and these two here. The average of those 6 is 50. And that should be what is reported here in table number 1 for the regular shelf width 50. And there's actually 6 numbers going into that average there. And then likewise for the width, wide width, we would just use these 6 here. Okay, so that's the construction of table number 1 when I have a non-significant interaction. When I have a significant interaction, what I got to do is worry about the combination of those variables. I can't look at them in isolation of one another. So let us suppose here that if the bakery example had a significant interaction, then what I would have to do is look at the bottom regular shelf width. I'd have to do these in combination of one another. So then I would be computing the average of the 47 and the 43, which gives me an average of 45. The n value, or the sample size here, would be 2 in that case. And then I would have another row for bottom wide, which would be the average of 46 and 40 here, which again has a sample size of 2 and would have an average of 43, is it? And then I'd have to figure out what the standard deviation is of those two numbers. So when the interaction term is significant, I got to do these averages kind of in combination of both of these variables. Whereas when the interaction term is not significant, I can look at all the bottoms and not worry about what shelf width I'm on. So there are differences in the construction of table number 1, depending on whether or not my model has interaction, or in the case of not having interaction, it's going to be like this here. So again, I just wanted to provide a little bit of clarification on that because it was not clear in class when I discussed table number 1. I think I was just too careless and said table number 1 is just the same, but there are differences there when I have interaction or don't have an interaction term. Now, on your assignment, I believe the assignment that I gave does not have a significant interaction term. So your table is going to be like the one here in this first example. Okay, that's all I have here for homework number 4, table 1 assistance. Have a good day.